It is Trial Exam 2019 SP paper, question number 7. State the principle of moments. Very simple, 2 marks. Clockwise equals anti-clockwise moments. Should add that in for a system to be balanced. So it's a classic moments question, as you are always going to get. The student uses the principle of moments to find the weight of a rock. This is the student's method. Balance the meter ruler at its midpoint. He hangs a beaker from the 40 centimeter mark on the ruler. He places the rock in the beaker. He then hangs a 0.2 Newton plastic strip from the ruler on the other side of the pivot. He adjusts the position of the plastic strip until the ruler balances. How could you measure, using electronic balance, that the plastic strip weighs 0.2 newtons? So you would measure the mass, use W equals M times G, where it's M times 10, I put the wrong way around, meters per second squared. And that's our 2 marks, pretty straightforward. Suggest how the student could improve the precision of one of his measurements. So he keeps on saying it's 40 centimeters, so maybe he could use a ruler, terrible spelling, with millimeters instead of meters. Centimeters, and then that's a bit of a more precise reading. Or he keeps saying he's going to measure the mass of things. So he's measured the mass of this thing, and he wants to make sure that's correct. So maybe if we used a balance with more decimal places, maybe that would be good. So precision is all about what is the smallest reading you can get from a piece of equipment. So vernier calipers are much more precise than a ruler, because a ruler may only go down to millimeters, but a vernier caliper can go down to hundredths of a millimeter. So that's a more precise piece of equipment. State the equation linking moment, force, and perpendicular distance. You can write it out, but you can also have moment equals F times D. That'll get you the 1 mark. Use the principle of moments to calculate the force. So first of all, we're going to work out, now this plastic strip is at 80 centimeters. So how far is it from the pivot? It's 30 centimeters. But newtons we're going to use meters for this because it just gives us a better reading. So we're going to work out that moment first because it's clockwise. We'll put it on this side, which is 0.2 times 0.3, which is 0.06. And then we're going to make that equal to the anti-clockwise moment, which is, now this is 10 centimeters away. So we're going to use 0.1 times F, and then F equals 0.06 divided by 0.1. So the force you should get is 0.6 newtons for 3 marks. Suggest a reason why the weight of the rock will be different from your calculated force. So it includes the weight of the beaker. So we also have the beaker pulling down on that side of the ruler, not just the rock, and we didn't take that mass into consideration. We also have the mass of the paper clip. Small, but it would change the weight that we measure. We want to just measure the rock. So either one of those for 1 mark, and that's question number 7.